This is the last example of two population variances. We're going to look at problem number 19 in page 466. Problem number 19 is about variance in production process. We have two machines that fills bags, and the bag weights of the first machine are given here. The bag weights of the second machine are given here. We want to see whether the variances are both the same or not. Okay, if they are different, then there is opportunity for decreasing the variances and see whether we can improve quality. So let's look at the Excel file. We have the data right here, machine 1 and machine 2. Population 1 is bag weights produced by machine 1. Population 2 is bag weights produced by machine 2. And sigma sub 1 squared is the variance of bag weights produced by machine 1, and sigma squared sub 2 is the same for machine 2. And we want to test whether the two machines are producing of the same quality, and therefore the alternative is that they are not equal to, which means the two are not the same, and that is they are the same in the null hypothesis. And the alpha value in this case is 5%. Now this time we are not going to set up the F statistic ourselves. We're going to use data analysis. So the F test can also be conducted using data analysis. So go to data, data analysis, and there is an option here for F test to sample for variances. That is the test you have to select and identify the range, first data range, the second data range, and of course labels. The default is 0.05 and that's what we're going to be using, and the output, I'll put it right there. And this generates the statistics that we want. So let's go ahead and format it a little bit. Now the mean is given in the first row, variances are given in the second row. Okay, let's increase the decimal places a little bit. Then the sample sizes, the degrees of freedom, then the F statistic is given, then the p-value for one-tailed test. And if you want two-tailed test, you have to multiply this by 2. Then you have the F critical for one-tailed test. We don't need to worry about that. So this is a two-tailed test. So we need to multiply that p-value by 2. So the conclusion is, since p-value is less than 5%, we reject H sub O. We have sufficient sample evidence to conclude the variances of bag weights produced by the two machines are not the same. The probability that this conclusion is wrong, that is type 1 error, is 0.0007%, or we could say it's nearly zero. Justify the text, and that's the last example we're going to look at in this chapter.